Hello pre-calculus students, and welcome to a video that introduces what polynomial functions are. Now we've talked about what a monomial is, but just a reminder, a monomial is a function of the form, this is a monomial function of the form f of x equals ax to the k, where a can be any real number, x is the independent variable, and it can be any real number, and then k would be an integer greater than or equal to 0. Okay. A polynomial is a sum or difference of monomials. And a polynomial function is just a function that's equal to some kind of polynomial. So a polynomial can be like ax squared plus bx plus c without an equal sign. It's not even an equation. It's just a set of terms. And a polynomial function is when you have a function equal to that set of terms. Okay, so degrees of polynomial functions are determined by the highest degree term. So if there's many terms, and there can be infinitely many terms, then the highest degree term determines the degree of the polynomial. Okay, so the simplest polynomial is just a no degree. There is not even any degree. We call that the zero function, and that's just the x-axis. And that is considered a polynomial function, but it's not the most interesting of polynomial functions. A 0 degree is when you have x to the 0 power, and that's some other horizontal line. It's a constant function where a is not 0, because if a was 0, that would make it the no degree function, and that's just a horizontal line. A first degree is a linear function in the form ax plus b. Now x is a first degree. So this is an oblique line. Okay, when x is the second degree, that's a second degree polynomial function. We call that a quadratic function. It looks like a parabola. Okay, now when we get more interesting is the third degree. Now the third degree polynomial function, this is the general form. You can see they just keep getting longer. We're just adding one term each time. The name of these are cubic functions. The graph is a cubic function, but this is an important one because let's think about the turning points of these. Now, if it's first degree, there's no turning points. It's just a line. It goes in the same direction. Now, we know that all parabolas are either going up or down. They're always U-shaped. And so we know that they all have exactly one turning point. Now, cubic functions can have up to 2 turning points, but never more than 2 turning points. So just a quick visual of a cubic function, just a real brief visual here would be, you have your parent cubic function that you know looks something like that, but you could also have one that has up to, because it's third degree, and we're going to learn this, we're going to get a whole set of notes on this, but whatever the degree is of the polynomial, the number of turning points can be up to 1 less than that. So there can be up to 2 turning points on this. So you can, for example, have a third degree that looks something like this. Maybe it goes up and then down and then back up and then down. So that's another variation of a third degree polynomial. And you can see it has a turning point here where there's a local max, those are the turning points, or a local min. Okay, so third degree can have no turning points. It can have 2 turning points. Can't have 1. But we're not really going to focus on even and odd, whether it can have an even or odd number. Just the fact that if it's third degree, the most it can have is 2, and that's the most you can get from any third degree polynomial. How can you tell from an equation whether it's a polynomial function? Well, these are all polynomial functions, and one thing they have in common is that there is no variable in the denominator. And so you can tell if there's a variable in the denominator or there's a negative exponent, this is not going to be a polynomial function. And the second one is a radical. You can't have a variable and a radical, which means you can't have a fractional exponent, like a exponent of 1/2 means square root, for example. So you can't have those. Those are the only things that are not polynomial functions, unless you have something that's like a trig function or a log function or something like that. Okay. Or even exponential function is not a polynomial function. All right, so let's take a look at some functions and decide whether or not they are polynomials. So here's 4 functions, and we're just going to use the test that we just talked about to decide. Now this one has a variable in the denominator. That means it's not a polynomial function. This one has a variable in a square root, which means it's not a polynomial function. This one has neither. That's a polynomial function. And this one is a polynomial function. So they're there. Okay? Now, all polynomial functions are smooth and continuous curves. There's no asymptotes, there's no holes. Unlike radicals, which we know end somewhere, doesn't happen with polynomial functions. They never end. They have unrestricted domains, smooth and continuous curves. So we say they're smooth and continuous. And just a little visual of that, what I mean by smooth and continuous. This is a polynomial function. Goes on forever. There's arrows on both sides. There's no holes, there's no gaps, there's no asymptotes. This would not be a polynomial function because it has a break in it. And you'll see a lot of rational functions that are also not polynomial functions. Okay, that's what a polynomial function is. Hope you found this helpful.